yesterday we've been talking about identifying key features of a parabola when given a graph. We're going to slowly start taking the graph away from you, and you can still find those key features and you will be able to graph. So today I'm going to show you ways to graph where you don't have to make a table of values. Remember when you graph with linear functions, it's like you find the y-intercept and then you go rise over run, rise over run, rise over run. It's similar to that, and we're going to lean on the parent function a lot. First, let's talk about finding zeros. Right now, you're still finding zeros from a graph. What is another word for zeros? X-intercepts. And x-intercepts are those values of x, a value of x that makes the function equal to 0. The zeros intersect the x-axis on the graph. For quadratics, you can have 2 zeros, 1 0, or no zeros, where it doesn't cross the x-axis. What are my zeros for example 1? So my values of x that make the function equal to 0, that make my y equal to 0, are 0 and 4. And let's look at that relationship within the context of the equation. If we plug in 0 for x into my equation, 0 squared minus 4 times 0 equals what? 0. That's a 0. Or if I plug in 4, 4 squared minus 4 times 4, 0. So that's how you can check for zeros in the equation. We haven't solved for them yet. I mean, you have solved by factoring before. Ooh, let's go ahead and solve by factoring. So can you factor x squared minus 4x? GCF, what is it? X, and then we leave. So the zero product property says that if a times b equals 0, then either x equals 0 or x minus 4 equals 0. So if x minus 4 equals 0, it would be 4. See how it kind of goes together? Tie it all together? 1 0. Here, where's my 1 0? Negative 1. And we can check that by plugging it in. Negative 1 squared plus 2 times negative 1 plus 1. What does that equal? It should equal 0, right? Because we're talking about zeros. When we have no zeros, we don't cross the x-axis. If we tried to factor this, well, there's nothing that multiplies to be 12 that adds to be negative 6. Now, any questions about x-intercepts? Are you kind of seeing how what we talked about in Unit 7 is connecting to what we're talking about in Unit 8? Let's talk about finding the axis of symmetry. Remember that the axis of symmetry is the vertical line that divides a parabola into two symmetrical halves. You know how to find it from a graph. So given this graph, what's my axis of symmetry? X equals 2. But did you know that there is a formula in which you can find your axis of symmetry so that you don't have to use a graph? Because I'm going to stop giving you graphs. You're going to have to find it without it. So in this formula, you need to know the values of a and b. But I like to know the values of a, b, and c from our standard form anyway. ax squared plus bx plus c is our standard form. In this case, what is a equal to? B is negative 4. And just for good measure, what is c? 0. So negative b over 2a, x equals, this is saying opposite b. So if it's negative 4, the opposite of that would be 4. Or over 2 times 1. What is 4 divided by 2? 2. So do you trust me? Do you see how that worked? Okay, so let's try it without the graph. What is a equal? For example 2. 1. What is b equal? And just to be sure, what is c equal? Okay, x equals, what's negative b? Negative 2 over 2 times 1. Negative 2 over 2 times 1. Now, this equation matches this equation. So this is our graph. Do you agree that my axis of symmetry is negative 1? Yes. Okay. So find your A. find your B, find your C, then find your axis of symmetry. So 6 over 2 times 3. So what does x equal? 1. If you look up here, this is the same graph, or this is the graph for the same equation. The axis of symmetry is that x equals 1. Finding the vertex. How would we find the highest or lowest point on our parabola? If you know the axis of symmetry. Here we knew that the axis of symmetry was 2. How could I find the y value? With just an equation, what would I do? Substitute. What? Yeah, we're going to put 2 in for x. 2 squared minus 4 times 2. 4 minus 8, negative 4. So if I have x is 2 and y is negative 4, then my vertex is at 2, negative 4, which you can see on this graph. But I want to make sure you know how to do it when you can't see it on the graph. This is the same equation as the page before. On example 2, what was our axis of symmetry?
Negative 1.
X equals negative 1. So what do I do with that negative 1? We substitute it in. We plug it in for x. So what is my value of y when at my axis of symmetry? 0. So my vertex is at negative 1, 0. My x value is negative 1. Plugged it in. My y value is 0. X, y pair for my vertex. What was my axis of symmetry for example 3? X equals 1. What do we do with that? Plug it in. What is my y value? What? 3 minus 6 is negative 3. Negative 3 plus 4 is 1. So my vertex is at 1. 1. Now we're going to use these key features. We're going to find the axis of symmetry. We're going to use that axis of symmetry to find our vertex. We're going to make a point for our vertex. We can find our y-intercept pretty easily. What's the definition of a y-intercept? Yeah, the point where x equals 0. If I plug in 0, I can get my y-intercept. And then I'll have 2 to 3 points, and then I can use my parent function relationship to fill in the rest. Okay, are you ready? So looking at number 1, first let's identify A, B, and C. What is A? 1. What is B? What is C? 0. Okay. X equals negative B over 2A. So negative B will be negative 2 over 2 times A. So what is my axis of symmetry? X equals negative 1. So I'm going to make a dashed line where x equals negative 1. We plug it in to get our y value of our vertex, because remember, our x value of our vertex happens at the axis of symmetry. So y equals negative 1 squared plus 2 times negative 1. Negative 1. So I make a point at negative 1. What is my y-intercept? 0, because if I plug in a 0 for x, 0 plus 0 is 0, so my y-intercept happens at the origin. And you can reflect that over the axis of symmetry, and now we have 3 points. Let's use our parent function to fill in more points. On our parent function, we go over 1, up 1. Over 2, up how many? 4, because 2 squared is 4. Over 3, up. So looking here, over 1, up 1, we already have a point there. When A is equal to 1, we can use that relationship, but we're going from the vertex, not the origin. So back to the vertex. Over 2, up 1, 2, 3, 4. Make a point. Reflect it over the axis of symmetry. Over 3, up 9. Make a point. Reflect it over the axis of symmetry. Connect your points with a beautiful curve. What is the domain of this function and all functions on this page? All real numbers. And what is my range? Y is greater than or equal to -1. The y value of my vertex. Okay, on number 2, what is A equal? What is B equal? What is C equal? So finding the axis of symmetry, x equals -b over 2 times A. What is my axis of symmetry? -2. X equals -2. So make a dashed line for your axis of symmetry where x equals -2. Plug that in to get our y value of our vertex. -2 squared plus 4 times -2 plus 2. -2. Will the x and y values for the vertex always be equal? No, that's just a fluke. I don't know why it's happening. -2, -2. So make a point at -2, -2. What is my y-intercept? When x equals 0, what does y equal? 2. So make a point at 0, 2. Reflect that point over your axis of symmetry. Let's use our parent function to fill in the rest of the points that we can. If a equals 1, then we can use the parent function and its relationship with the vertex to graph a lot more points. So remember, on our parent function, we go over 1. How much do we go up? 1. Over 1, up 1. If I go over 2, how much do I go up? And those points are already there. Over 2, up 4 is already there, because that was our y-intercept. So go over 3, up how many? 9. What is the domain of this function and all functions on this page? All real numbers. What is my range? Y is greater than or equal to -2. Ready for number 3? What is A equal to? B is equal to? And C equals 0. So axis of symmetry, x equals -b over 2a. What is my axis of symmetry? X equals -2. So make a dotted line where x equals -2. To get our y value, we plug in -2. Y is equal to 4. Does everyone understand why this is a -4 right here? Because you square the -2, you get 4, but it has a negative in front of it, so it's got to remain negative. So we make a point at -2, 4. Where's my y-intercept? 0, 0, because the value of c is 0. And you make a point there, and you reflect it over your axis of symmetry. Now let's use our relationship with our parent function to graph more points. Usually our parent function opens upward. But because of this negative, we're opening downward. But it's still a 1, so we can follow that pattern. Okay, so over 1, down 1, and reflect. Over 2, down 4, but there's already a point there because of our y-intercept. So we got those. Over 3, how far down am I going to go? 9. Now remember, when we say down 9, we're talking about from the vertex, not the origin, not from the previous point, but from the vertex. Over 3, down 9. And reflect that over your axis of symmetry. What is the domain of this function? And my range? Number 4. What is A? 2. What is B? 0. What is C? -8. So x equals 0 over 2 times 2. But that still equals 0. So my axis of symmetry is 0. When you do not see the B term, your parabola is going to be symmetrical around the y-axis. So plug in 0. My vertex will be at 0, what? -8. But where's my y-intercept? 0, -8. So here is when our vertex is the same as our y-intercept. that you have a couple options to graph. You can make a table of values, plug in 1 for x, get a y, plug in 2 for x, get a y, and work there. Or you can try and see how this relates to the parent function. So my parent function is x squared. Here, where we're looking at our first term, it's 2x squared. So instead of going over 1, up 1, I'm going to go over 1, up 2, and reflect that across my axis of symmetry. Instead of going over 2, up 4, I'm going to go over 2, up 8. Over 3, up 18. And you can check these points on a table if you plug in a 1. 1 squared is 1, times 2, minus 8, negative 6. 4 times 2 is 8, minus 8, 0. 9 times 2 is 18, minus 8 is 10. Okay, domain, range. Y is greater than or equal to negative 8. Something I want to talk to you about before you move on or go into anywhere. After we graphed, there are lots of places where you could tell me the x-intercepts. So I know I didn't ask for the x-intercepts here, but you can see them on this graph. You can see them as integers here, and you can see them as integers here.